Power and Ground Engineering specializes in power distribution, grounding, and electromagnetic compatibility, also known as EMC solutions. Power One is a leading provider of power distribution systems, including rack power distribution units known as PDU. Eaton is a global power management company with expertise in rack power and grounding systems. Vertiv is a provider of critical infrastructure technologies, including power and cooling solutions for data centers. Schneider Electric is a multinational company specializing in energy management and automation, including rack power and grounding systems. Several companies also have expertise in rack room power, ground systems, and satellite communications. Viasat is a satellite communications company with expertise in satellite gateways and ground systems. Gilat Satellite Networks is a provider of satellite networking solutions, including gateways and ground infrastructure. Hughes Network Systems is a satellite communications company specializing in broadband satellite connectivity. Inmarsat is a provider of global satellite communications services, including satellite gateways. Intelsat is a satellite communications company with expertise in satellite gateways and ground networks. It is recommended to contact multiple expert companies. Request proposals and technical consultations from the recommended companies. Assess their experience and references. Inquire about their experience in rack room power and ground systems and satellite communications. Consider their approach and recommendations. Evaluate their proposed solutions and how they address specific issues. Engage a qualified expert. Hire an expert with proven experience in both rack room power and ground systems and satellite communications. Additional tips to consider include conducting a thorough site assessment. Analyze the current rack room power and ground systems to identify potential issues. Consider environmental factors. Account for factors such as temperature, humidity, and electromagnetic interference. Implement best practices. Follow industry standards and guidelines for rack room power and grounding systems. Monitor and maintain the systems. Regularly monitor and perform maintenance to ensure optimal performance. When dealing with rack room power and grounding systems, it's important to understand some fundamental concepts. Electrical grounding ensures a safe path for fault currents, protecting equipment and personnel from electrical shock. A properly grounded system also minimizes electrical noise, which can interfere with sensitive electronic equipment. Grounding involves connecting conductive parts of the system to the earth, providing a low impedance path for current to flow in the event of a fault. Bonding involves connecting different conductive parts of the system together to equalize their potential, reducing the risk of voltage differences that can cause electrical shock or create noise. Electromagnetic compatibility, EMC, refers to the ability of equipment to function without causing or being susceptible to electromagnetic interference. In rack rooms, EMC is crucial for maintaining the integrity of data signals and preventing equipment malfunction. Power distribution units, PDUs, are used to distribute electrical power to the various devices in a rack. They often include features such as surge protection, power monitoring, and remote control. When selecting a PDU, it's important to consider the power requirements of the equipment being powered, the number of outlets needed, and any special features that may be required. There are several industry standards and guidelines that provide recommendations for rack room power and grounding systems. These include the National Electrical Code, also known as NEC, and various standards from organizations such as the Institute of Electrical and Electronics Engineers, also known as IEEE, and the Telecommunications Industry Association, also known as TIA. These standards cover topics such as grounding, bonding, wiring, and equipment installation. When conducting a site assessment, it's important to evaluate the existing power and grounding infrastructure. This includes inspecting the grounding system, checking the wiring for proper connections and insulation, and measuring the voltage and current levels. It's also important to identify any potential sources of electromagnetic interference, such as nearby radio transmitters or industrial equipment. Environmental factors can also affect the performance of rack room power and grounding systems. Temperature and humidity can affect the conductivity of materials and the performance of electronic components. Electromagnetic interference can be caused by a variety of sources, including radio transmitters, industrial equipment, and even lightning strikes. Proper grounding and shielding can help to minimize the effects of electromagnetic interference. Best practices for rack room power and grounding systems include using a dedicated grounding conductor, bonding all conductive parts of the system together, and using shielded cables and connectors. It's also important to regularly monitor and maintain the systems to ensure optimal performance. This includes checking the grounding connections, inspecting the wiring, and testing the surge protection devices. By following these guidelines, it's possible to create a rack room power and grounding system that is safe, reliable, and provides optimal performance. Consider these specific elements to improve rack room power and grounding. Firstly, grounding and bonding networks are critical for safety and performance. The grounding system ensures a low impedance path for fault currents, protecting equipment and personnel. The bonding network connects all metallic parts to equalize potential, preventing voltage differences. Secondly, surge protection devices, SPDs, protect equipment from voltage spikes caused by lightning or power surges. SPD should be installed at the service entrance and at individual racks to provide comprehensive protection. Thirdly, power distribution units, PDUs, distribute power to the equipment in the rack. Intelligent PDU provide monitoring and control capabilities, allowing remote power cycling and energy management. Fourthly, cable management is important for maintaining airflow and preventing cable damage. Proper cable management also makes it easier to troubleshoot and maintain the system. Fifthly, environmental monitoring systems track temperature, humidity, and other environmental factors. These systems can alert administrators to potential problems before they cause equipment failure. Sixthly, uninterruptible power supplies, UPSs, provide backup power in the event of a power outage. UPS are essential for maintaining uptime and preventing data loss. Seventhly, electromagnetic interference, EMI, shielding reduces the impact of external noise on the system. Shielded cables and enclosures minimize interference and improve signal integrity. Eighthly, regular maintenance includes inspecting grounding connections, testing SPD, and verifying proper airflow. Proactive maintenance prevents problems and ensures the long-term reliability of the system. Ninthly, documentation is essential for troubleshooting and future upgrades. Accurate records of grounding systems, cable layouts, and equipment configurations streamline maintenance. Tenthly, consider consulting with experts to assess and optimize the rack room power and grounding systems. Professional guidance ensures compliance with industry standards and best practices. Rack room design significantly impacts the performance and reliability of the equipment housed within. Proper power and grounding are not merely afterthoughts but integral aspects of the design process. Firstly, a comprehensive grounding system is essential. This involves creating a low impedance path to earth for fault currents, which protects equipment from damage and reduces the risk of electrical shock. The grounding system should adhere to relevant standards such as the National Electrical Code, NEC, in the United States, or equivalent standards in other regions. Secondly, bonding is a critical component of the grounding system. Bonding involves connecting all metallic parts of the rack, including the frame, enclosures, and cable trays to equalize their electrical potential. This prevents voltage differences that can cause noise and interference. Thirdly, power distribution is another key consideration. Power distribution units, PDUs, should be selected based on the power requirements of the equipment in the rack. Intelligent PDU offer features such as remote monitoring and control, which can be valuable for managing power consumption and identifying potential problems. Fourthly, surge protection is essential for protecting equipment from voltage spikes caused by lightning or other power surges. Surge protection devices, SPDs, should be installed at the service entrance and at individual racks to provide comprehensive protection. Fifthly, cable management is crucial for maintaining airflow and preventing cable damage. Cables should be neatly organized and routed to avoid obstructing airflow and to prevent them from being pinched or crushed. Sixthly, environmental control is important for maintaining the optimal operating temperature and humidity for the equipment in the rack. This may involve installing air conditioning units, humidity control systems, and ventilation systems. Seventhly, monitoring systems can be used to track environmental conditions and power consumption. These systems can alert administrators to potential problems before they cause equipment failure. Eighthly, documentation is essential for troubleshooting and future upgrades. Accurate records of the grounding system, power distribution system, and cable layouts can streamline maintenance and make it easier to identify and resolve problems. Ninthly, consider the specific requirements of the equipment being housed in the rack. Some equipment may be more sensitive to noise and interference than others and may require special grounding or shielding. Tenthly, regular maintenance is essential for ensuring the long-term reliability of the rack room. This includes inspecting grounding connections, testing surge protection devices, and verifying proper airflow. Proper rack room design is a complex undertaking that requires careful planning and attention to detail. By addressing these key considerations, it is possible to create a rack room that is safe, reliable, and efficient. Addressing power quality is essential for rack rooms. Power quality refers to the characteristics of the electrical power supply, including voltage stability, frequency stability, and harmonic distortion. Poor power quality can cause equipment malfunction, data loss, and premature equipment failure. Firstly, voltage regulation is important for maintaining a stable voltage supply. Voltage sags and surges can damage equipment and cause data loss. Automatic voltage regulators, AVRs, can be used to stabilize the voltage supply and protect equipment from voltage fluctuations. Secondly, frequency stability is important for ensuring the proper operation of equipment that is sensitive to frequency variations. Uninterruptible power supplies, UPSs, can provide a stable frequency supply during power outages. Thirdly, harmonic distortion can cause equipment to overheat and malfunction. Harmonic filters can be used to reduce harmonic distortion and improve power quality. Fourthly, transient voltage surge suppression, TVSS, protects equipment from voltage spikes caused by lightning or other power surges. TVSS devices should be installed at the service entrance and at individual racks to provide comprehensive protection. Fifthly, grounding and bonding are essential for minimizing noise and interference. A properly grounded and bonded system provides a low impedance path for fault currents and reduces the risk of electrical shock. Sixthly, power conditioning equipment can be used to improve power quality by filtering out noise and regulating voltage. Power conditioners are available in a variety of configurations, including line conditioners, power purifiers, and isolation transformers. Seventhly, power monitoring equipment can be used to track power quality parameters such as voltage, current, frequency, and harmonic distortion. This information can be used to identify potential problems and optimize power consumption. Eighthly, uninterruptible power supplies, UPSs, provide backup power in the event of a power outage. UPS are essential for maintaining uptime and preventing data loss. Ninthly, isolation transformers can be used to isolate sensitive equipment from the power supply. Isolation transformers can reduce noise and interference and improve power quality. Tenthly, regular power quality audits can be used to identify potential problems and ensure that the power supply is meeting the requirements of the equipment. Power quality is a critical consideration for rec rooms. By addressing these key considerations, it is possible to ensure that the equipment is receiving a clean and stable power supply, which can improve equipment reliability and reduce the risk of data loss. Here are details on grounding techniques. Grounding is a critical aspect of electrical safety and electromagnetic compatibility in rec rooms. A well-designed grounding system provides a low impedance path for fault currents, protects equipment from damage, and reduces the risk of electrical shock. Firstly, single-point grounding is a grounding technique in which all grounds are connected to a single point. This minimizes ground loops and reduces noise. Secondly, mesh grounding is a grounding technique in which a grid of conductors is used to provide a low-impedance ground path. This is particularly effective in reducing noise and interference. Thirdly, isolated grounding is a grounding technique in which the ground conductor is isolated from the building ground. This can be used to reduce noise and interference in sensitive equipment. Fourthly, equipment grounding is a grounding technique in which the metal chassis of equipment is connected to the ground. This provides a path for fault currents and reduces the risk of electrical shock. Fifthly, signal grounding is a grounding technique in which the ground conductors for signal cables are connected to the ground. This reduces noise and interference in signal cables. Sixthly, bonding is a grounding technique in which all metallic parts of the rack, including the frame, enclosures, and cable trays, are connected together to equalize their electrical potential. This prevents voltage differences that can cause noise and interference. Seventhly, grounding conductors should be sized according to the National Electrical Code, NEC, or other applicable standards. The size of the grounding conductor should be based on the size of the circuit conductors. Eighthly, grounding connections should be made using approved connectors and methods. Grounding connections should be tight and corrosion resistant. Ninthly, grounding systems should be tested regularly to ensure that they are functioning properly. Grounding tests should be performed by qualified personnel. Tenthly, documentation of the grounding system is essential for troubleshooting and future upgrades. Accurate records of the grounding system can streamline maintenance and make it easier to identify and resolve problems. Grounding is a critical aspect of rack room design. By using appropriate grounding techniques and following applicable standards, it is possible to create a safe and reliable electrical system. Electromagnetic compatibility (EMC) is crucial in rack rooms to ensure the reliable operation of sensitive electronic equipment. Electromagnetic interference (EMI) can disrupt data transmission, cause equipment malfunction, and even lead to permanent damage. Therefore, implementing effective EMC measures is essential. Firstly, grounding and bonding form the foundation of EMC. A well-designed grounding system minimizes ground loops and provides a low-impedance path for noise currents, preventing them from affecting sensitive circuits. Bonding ensures that all metallic parts are electrically connected, preventing voltage differences that can drive interference. Secondly, shielded cables and connectors are vital for reducing EMI. Shielded cables have a conductive layer that surrounds the conductors, blocking electromagnetic fields from entering or exiting the cable. Shielded connectors maintain the shielding integrity at the connection points. Thirdly, filtering is used to suppress unwanted frequencies. Filters can be installed at the input of equipment to block incoming noise or at the output to prevent noise from radiating out. Fourthly, enclosures provide a physical barrier against EMI. Metal enclosures are particularly effective at blocking electromagnetic fields. Enclosures should be properly grounded to ensure that they function effectively. Fifthly, cable management is important for minimizing EMI. Cables should be routed away from noisy equipment and kept as short as possible. Cables should also be bundled together and secured to prevent them from moving around and radiating noise. Sixthly, proper layout and spacing can reduce EMI. Equipment should be arranged so that noisy equipment is located away from sensitive equipment. Spacing between equipment should be sufficient to prevent electromagnetic fields from interfering with each other. Seventhly, testing and certification are important for ensuring that equipment meets EMC standards. Equipment should be tested to ensure that it does not generate excessive EMI and that it is immune to EMI from other sources. Eighthly, transient voltage surge suppression (TVSS) protects equipment from voltage spikes caused by lightning or other power surges. TVSS devices should be installed at the service entrance and at individual racks to provide comprehensive protection. Ninthly, regular maintenance is essential for ensuring that EMC measures remain effective. Grounding connections should be inspected regularly to ensure that they are tight and corrosion resistant. Cables should be inspected for damage and replaced if necessary. Tenthly, training and awareness are important for ensuring that personnel understand EMC principles and follow proper procedures. Personnel should be trained to identify potential sources of EMI and to take steps to minimize it. By implementing these EMC measures, it is possible to create a rack room environment that is free from excessive EMI and that ensures the reliable operation of sensitive electronic equipment. Regular maintenance is crucial for ensuring the long-term reliability and performance of rack room power and grounding systems. A proactive maintenance program can identify potential problems before they cause equipment failure, data loss, or safety hazards. Firstly, visual inspections should be performed regularly to check for any signs of damage or deterioration. Look for frayed cables, loose connections, corrosion, and any other abnormalities. Secondly, grounding connections should be tested periodically to ensure that they are tight and corrosion resistant. Use a ground resistance tester to measure the resistance of the grounding system and compare it to the manufacturer's specifications. Thirdly, surge protection devices, SPDs, should be tested regularly to ensure that they are functioning properly. Use a surge protection tester to verify that the SPD are able to divert surge currents effectively. Fourthly, power distribution units, PDUs, should be inspected and tested to ensure that they are providing clean and reliable power. Check the voltage and current levels at each outlet and verify that the PDU is not overloaded. Fifthly, uninterruptible power supplies, UPSs, should be tested regularly to ensure that they are able to provide backup power in the event of a power outage. Perform a battery load test to verify that the batteries are able to support the load for the specified runtime. Sixthly, environmental monitoring systems should be checked to ensure that they are functioning properly. Verify that the temperature and humidity sensors are accurate and that the alarm thresholds are set appropriately. Seventhly, cable management should be reviewed to ensure that cables are properly organized and routed. Check for any cables that are pinched, frayed, or obstructing airflow. Eighthly, documentation should be kept up to date. Maintain accurate records of all maintenance activities, including dates, findings, and corrective actions. Ninthly, cleaning should be performed regularly to remove dust and debris. Use a vacuum cleaner with a HEPA filter to remove dust from equipment and surfaces. Tenthly, training should be provided to personnel on proper maintenance procedures. Ensure that personnel are familiar with the location of all critical components and that they know how to perform basic troubleshooting tasks. By implementing a comprehensive maintenance program, it is possible to extend the lifespan of rack room power and grounding systems, improve their reliability, and reduce the risk of costly downtime.